Ocean waves are actually energy traveling through the water. Now, it's important to realize that it's the energy moving and not the water itself. And as the energy moves through this water, it shapes the water into the form of a wave.
Normal waves come ashore all the time without creating damage. But tsunami waves are unusual. It can be devastating.
Yes, and tsunamis aren't detected out at sea. Well, not unless we use a lot of technology, that is. So when the fishermen would come back to their harbor and find it destroyed by a giant wave, well, they called that a harbor wave. And the word tsunami means in Japanese, harbor wave.
Oh. As the name suggests, tsunamis are still just waves. But the difference from normal waves is that they carry a huge amount of energy, such as energy from an earthquake.
And as the wave nears the shore, the energy concentrates into a wall of water that can run miles inland, sometimes creating terrible destruction and loss of life.
Imagine a packet of wave energy as an array of tiles.
In the deep ocean, the tsunami is stretched out over a long distance.
And a boat would travel over the wave without hardly noticing.
As the wave packet nears the shore, the wave slows, because the wave speed is related to the square root of the depth. So the decrease in speed causes the wavelength to decrease.
The wave still has the same amount of energy, just rearranged. But now the wave is so big, it can hardly fit at sea level anymore.
So the wave has to rise above sea level. This creates a towering mountain of water, which hits the land with great power.
So the tsunami draws water in from all around the wave.
The tsunami often begins with what looks like an enormous low tide. It literally draws the water away from the shore before it hits.
Some areas are more or less prone to tsunami damage. For example, if the shoreline is taller than the wave, like a cliff, the wave will crash against it, but not over it.
But on the other hand, if there's a large area of shallow water just offshore, there's less water for the tsunami to take in, and the energy is absorbed into the ocean bottom.
The shape of the shoreline makes a big difference too. If the shoreline is sloped, then water gets driven higher as it gets crammed into a smaller and smaller space.
Scientists try to identify all the factors involved when making a tsunami dangerous to know where to focus on public safety.
That's why they seek to understand the way tsunamis are created, the way the waves behave, the way the shoreline is shaped, the way people behave when they are warned of approaching danger.
So seismologists, geologists, even psychologists and sociologists all get involved when studying tsunamis.
And emergency management professionals in local and federal government agencies make policies and plans to help protect people and property.
That's right. And you can see a link to the U.S. government's research on our website.